If I threw a ball at a rate of 19.6 meters per second from a building that was 34.4 meters tall. So meters, right? That's one thing to notice here. We're in meters. So if I threw it from a building, I guess what do you think of that as up or down? I don't know. If I threw a ball at a rate from a building, what should we make that? Let's say up. Up at a rate. Could be down too. So let's look at what we know. Gravity in this case is 9.8 meters per second squared. Our initial velocity is upward of 19.6 meters per second. Our initial height is 34.4 meters. So that's all I need to know to solve this problem. So let us graph it. And the way we graph it, of course, is to get it in vertex form. So h of t equals negative 1/2 times 9.8 t squared plus my initial velocity times t plus my initial height. So this computes to negative 4.9 t squared plus 19.6 t plus 34.4 equals my initial height. So completing the square, I need to get my c value over to the other side. So I have h of t minus 34.4 equals negative 4.9 t squared plus 19.6 t. And now divide both sides by negative 4.9, negative 4.9, and the whole thing negative 4.9. And so now I'm left with h of t minus 34.4 all over negative 4.9 is equal to t squared minus 4t. Now I'm ready to complete the square. Plus what? Plus what? Half of negative 4 squared should give me 4. So I'm adding 4 to both sides. So completing the square, this is t minus 2, quantity squared. So that's half of b is equal to this thing over here. So just to make my life easier, I'm going to subtract 4 from both sides in this one step. So I'm left with h of t minus 34.4 all over negative 4.9. Continuing, I'm going to multiply both sides by negative 4.9 because that's the next thing I need to undo here, because the whole thing is being divided by that. So negative 4.9 quantity t minus 2 squared minus, plus, because negative times negative, and I get 4 times 4.9 is 19.6 is equal to h of t minus 34.4. So now I add 34.4 to both sides. I get minus 4.9 t minus 2 squared plus 54 equals my height. Convenient number, because now I know my vertex is at 254 and my a value is negative 4.9. So at 2, 54, again I don't have enough space here. So if I made each thing worth 5, this would be 5, 10, 15, 20, 30, 40, 50, 54 would be right here, and it'd be about at 2. So that's my vertex 254. And I know it's negative. I know my y-intercept from my initial equation, which was 34.4. So I can find that on the graph. 34.4 roughly there, and a point symmetric. 1, 2 over, 1, 2 over. So we know it's a parabola that roughly looks like that. And we want to find out where it crosses. Now my drawing is terrible, right? So you don't really know that it crosses at 5 or anywhere near 5 based on how I drew it. So let's find out exactly where it does cross by setting h of t to 0 and solving the vertex form. So 0 equals negative 4.9 t minus 2 squared plus 54. I subtract 54 from both sides. Negative 54 equals negative 4.9 t minus 2 squared. So I'm going to take negative 54 and divide it by negative 4.9, and I get 11.02 equals t minus 2 squared. Take the square root of that, and I get plus and minus 3.32 is equal to t minus 2. Just so you see it, I took the square root of both sides. And then I'm adding 2 to both sides, so I get 2 plus and minus 3.32, which is roughly either 5.32 or minus 1.32 in seconds. So obviously the negative doesn't make sense in this context, so when does it hit the ground? 5.32, so probably more like over there. So 5.32 seconds. How high would it go? 54 feet, that's my vertex. When would it reach there? 2 seconds. So you can see once we get into vertex form, we could answer a lot of questions.